Hello everyone to my presentation about how to set up Bitcoin and Monero cold storage in Qubes OS. My name is Piotr Król, I am 3MDEP founder and CEO. I'm Coreboot contributor and maintainer, a conference speaker and co-organizer. I'm trainer for various organizations and I'm former Intel BIOS software engineer. I'm in business 12 years and probably for like 5 or more using Qubes OS. I'm also a C-level person in couple other organizations, which logo you can see on this slide. Who we are, who's 3MDEP? We are a Coreboot licensed service provider since 2016 and leadership participants. We are UEFI adopters since 2018, Yocto participants and embedded Linux experts since 2019. And we are official consultants for Linux Foundation FWPD LVFS project since 2020. As well as IBM Open Power Foundation member since 2020. Our firmware engineer Michał is also System Software Working Group chair in Open Power Foundations starting this year. Okay, what I will talk about today. So first of all, I will start with presentation goal, then a little bit about terminology, architecture of the solution, like basic diagram of that. Then I will get you through setup of the Bitcoin wallet, Bitcoin cold storage VM, Bitcoin online watch only wallet, as well as I will show how to receive and transmit coins. Then I will talk a little bit about QRXZ and Qubes OS RPC, and I will show send to sign and sign transaction RPC services, like a sample source code for that. Then I will present Bitcoin demo, which will show how those services can be used for signing Bitcoin transactions. After that, I will try to do the same with Monero, but fast forward without a lot of details, just the most important things plus demo. And then I will discuss future ideas and we can switch to questions and answers. So first of all, the goal of the presentation is to demo offline wallet for Bitcoin and Monero with Qubes OS. But please note that I'm by no means a cryptocurrency expert, and anything I will show here should not be considered as a state of the art. It's rather experimentation and proof of concept. And if you want to set up something what would be really secure, you should consult domain experts. And yeah, we are not responsible for any damage caused by using materials from this presentation. Okay, first of all, let's start with what is cold storage. On the top you'll see interesting picture of ancient 1920 cold storage for keeping some food and other stick. But of course we're not talking about that. We're talking about some computing device, some offline computing device which can keep private component of the cryptocurrency, so we do not expose that private components to potential remote access attacks. And of course, by keeping private components of our cryptocurrencies into cold storage, we reduce attack surface to the minimum based on the cold storage that we use. The idea behind that is that public key or public part of our wallet is used in the online watching only wallet, where we see incoming transaction and we can see what's going on, but there is no way to use that for doing any transaction. To do the transaction, we have to create kind of transaction file, which I will discuss further, transfer it to the cold storage, use the private key to authorize transaction and broadcast that to the network. So the architecture looks as follows. We have any VM or whatever VM we have with watch only online wallet. And when we want to do some transaction, we create transaction file, we transfer that to cold storage VM where we have offline wallet. And this offline wallet can do the signing process because it has access to private key, and then the signed transaction can be sent to watch only wallet to broadcast that to the network. We can also use offline wallet to generate payment requests, because at least for Bitcoin this is valid because it knows the potential address on which we can receive the coins. The limitation of this architecture is that maybe it can be hard in using in high frequency trading, but this is for completely different purposes, and I believe there is some space for optimization here. For the wallet that we will use in further examples, we chose Electrum. Electrum was created by Thomas Vogetlin, sorry for mispronouncing the surname, in November 2011. The wallet is written mostly in Python, and its source code is available on GitHub. We will use version 4.1.5 app image, and it meets our needs because we want to use Linux. We are okay with advanced features and kind of dealing with command line interface. We want to have open source license, and we want to have reasonably lightweight setup which can be run on machine with very little memory. So yeah, we decided that Electrum meets all those criteria, plus it has some additional features that may be useful in future when this concept will grow. So let's start with creating Bitcoin cold storage VM using minimal template. First of all, it would be great if you could enable minimal templates if you don't have that. You can do that in DOM0 through using Qubes DOM0 update and installing Qubes template Debian 10 minimal. Then you can enable networking because we have to install some additional dependencies for Electrum. In that way you can run terminal, and in the terminal you can simply install Fuse, which is Electrum dependency. Then you can create a Bitcoin cold storage VM. We gave it black label. Minimal memory is 1.8 megs, maximum memory is 256, and we're using Debian 10 minimal as a template. After that, it would be great if you could take some of your trusted VM where you are comfortable doing signature verification, and using those commands above, so you can verify signatures. The signatures are also on the server. So yeah, then you can verify if the app image is correctly signed. And fingerprints can be found on GitHub and on the Electrum.org about page. Then to deploy Electrum to Bitcoin, you just QVM copy to the correct VM. You run some terminal in that VM, so we can proceed with further steps. We need to add executable bit, and then we can run the Electrum wallet daemon, and we can create some wallet. Please note we're using testnet, so everything here is just on the testnet. It will not go to the mainnet, so it is safe to experiment in that way. If you would like to restore the wallet in future, make sure to save the seed of the newly created wallet. Then to use the wallet which was created with the create parameter, you just load wallet and you can start using it. After loading, you can run list wallets, and you can see on the above that in Bitcoin cold storage we can see status of our wallet and the directory where it is stored. Then we can also get some more information about this wallet. If you need that, you can see that this is 4.1.5 version, and other details. What is important right now, you have to export the master public key to use it to create a watch-only wallet based on that. The most easy way is just use the command get mpk and copy that mpk and tee that to some file, and copy that file to the VM where the watch only wallet will be used. Then in the VM where you want to create online watch-only wallet, you're just going through running graphical user interface, and you can just use standard default name of the wallet. Then you're choosing standard wallet. You're choosing that you would like to use master key that you already have, and then you're just pasting or reading from the MPK file that we copied master public key into this window. Please note that that previous commands that I show add the new line at the end, and this may cause that the next button will not be active. If you want, you can set up password. For testing, we will not do that. And then suddenly when you enter the Electrum, you see that it's saying that please note that you are in test mode and all the coins are worthless, and there is no this is just for playing. Yeah. Next pop-up would be that the wallet is watching only mode, and that you cannot spend any bitcoins with that. You have to create transactions and transfer those to the cold storage for signing. Okay, so first of all, to do any transactions, to even test anything, we would like to receive some coins. To do that, you can create a request just to get some first unused address, Bitcoin address, to which you would like to receive this amount of Bitcoins, and then just going to some testnet faucet where you can send the Bitcoins. In this case, we're using testnet faucet mempool CO. And this works quite fast, at least for me. And then you receive this TBTC, so testnet Bitcoins, which are, as we said, no value, just testing, just for testing needs. Then when you want to send coins to someone, if you want to send to anyone, you're just going to send and giving address, giving the amount, and just clicking pay and send. Then you want going to transaction, export that file, and then this file should be transferred to our cold storage VM. And in this cold storage VM, we have to convert this partial transaction file. Since it is in binary form, we have to convert it to base64, because that's the format that is understood by Electrum application. And then we're using parameters -- testnet to indicate that this is for testnet, and there is command called sign transaction and dash to consume standard input. And as output, we receiving signed transaction associated with this partial transaction. When we copy that back, we can load that to Electrum wallet. Okay, so that was kind of how manually procedure look like. So let's talk a little bit about the QR exec and Qubes OS RPC. The basic information you need to know is that there is QR exec framework, which consists of multiple binary scripts, which implements communication between the domains, between the VMs. It is built on top of vChan, which is Zen library, which gives ability to build links between virtual machines for communication purposes. Every communication that is set up between two VMs so the communication is set up through DOM0, and DOM0 kind of have to allow for that communication, but then transfer is directly between VMs. And thanks to that framework, we can create remote communication, like a kind of client-server communication using scripts in quite easy way. And the client side, so if we are in VM, which is client, let's say our watch-only Electrum wallet VM is a client for the Bitcoin cold storage VM, which keeps secret key, which can sign transaction. Yeah? So we can consider that part as a server. And we're using QRExec client VM to make calls to this server VM. Yeah. So when those calls are made, we get through DOM0, and DOM0 checks if the policy implemented say that this is allowed. Yeah. And sometimes we may get even a pop-up saying like, are you okay with this, or please choose target VM, or are you okay with this kind of call? And then if we approve that, then some script or some stuff is executed on the server side. There is also a way to transfer standard input, standard output to exchange data between the client and server side in this configuration. Yeah, on the picture you can see that how the communication between DOM0 and some VM may be established using like from DOM0 to some VM may be established using QRExec framework. Okay, so when we know that, then how we could create some service that will simplify execution of the signing process for assuming that the private keys are in Bitcoin cold storage VM. So first of all, there is no sudo access as in other VMs for Debian 10 minimal. That's why we have to run xterm with user root, and then we can create stuff in etc Qubes RPC, which is where the all the RPC stuff is stored in our Bitcoin cold storage VM, and we create file test sign transaction. It looks as follows. We're just saying like where is the Electrum application. We showing how we can get arguments which will be processed further. Of course, if there is no argument, we returning error, and then we calling our Electrum application in testnet. We're doing sign transaction. We're doing separation of the incoming parameters, and then just to avoid the situation where someone will try to pass in argument some option for the Electrum or for the sign transaction subcommand. So this is kind of security improvement. Without it, it could be possible to pass some sign transaction or Electrum arguments inside the argument variable. In that case, we expect here our partial transaction or some transaction for signing. In DOM0, we have to define what would be the communication allowed. So we're saying that any VM can communicate with Bitcoin cold storage, but we will see the pop-up asking for confirmation. And then with the VM that's sending data, we have to comply with what's expected by a test sign transaction. So test sign transaction expects some standard input and then provides on standard output the signed transaction. So in this case, as a parameter, we're creating etc Qubes RPC tests sent to sign, and this script will take as a parameter some file, which in this case should be partial transaction file. It is provided to the other end of RPC, and then we expect that there is a standard output coming from the remote and from the server, and this would be dumped as output. So what you will see in the demo. Yeah, so let's start with the demo. On the top you can see Electrum wallet, and on the bottom is a terminal from the VM where the watch only Electrum wallet is running. So first of all, we're just getting faucet Bitcoin address for testnet. to send some bitcoins there. We're sending like 1 MBTC. We create payment and then we export that. So this was added to wallet history. We export that partial payment, partial transaction, and that partial transaction have to be converted because it's in binary form. So we convert it using base 64 to create transaction file, to create unsigned transaction. And that unsigned transaction then will be transferred using QRexec service that I explained before. And now we using QRexec. First parameter is target VM. Second parameter is the service that we want to run, and third parameter is the file, the script that sending the unsigned transaction file. As you saw, we get pop-up where we should run the transaction. We pointed to BTC CS VM. We received signed file, signed transaction, and now we can save it and broadcast. And you can see that the broadcast was correct because the signature was verified. And now we have unconfirmed transaction, and at some point after some time this transaction will be verified by the testnet. So second part of the presentation would be about Monero. For Monero, there is official command line wallet developed by Monero community. This is written mostly in C++. The source code is available on GitHub. License seemed to be BSD with some nodes for other components that were used in the project. We used Oxygen Orion, which is version 0.17.2.0, and of course it meets the same requirements that we had before. As before, we're starting with creation of Monero cold storage VM based on Debian 10 minimal template. Then there are no additional dependencies, but if someone would like to need some additional tools, additional stuff, then that's good place and moment to install it. Then we're doing signature verification according to wallet documentation. It is on the download page. It's explained on the download page how to do that. And then we transfer, of course, in our wallet to Monero cold storage because that VM does not have access to the network. And so first of all, we start daemon on the StageNet. So Monero has 3 networks: mainnet, StageNet, testnet. Testnet is where all the developer features are created. StageNet is where safely stable version of Monero can be used. So that's why we're using StageNet, to just avoid problems related to the testnet and moving target. So we have to start Monero daemon, and then this daemon, of course, we're starting that inside Monero cold storage. And when we have started Monero daemon, then we can start also Monero command line wallet. And it gets that through getting started procedure, asking where wallet should be stored, and a couple other information. And then we can create Monero watch only. To do that, we need 2 things from our cold storage. First thing is the address of the wallet that was created, and then we also need to obtain private view key. So the key which allows us to view the chain and view the transactions that's going on for us. And you can obtain that through view key, and there are 2 pieces: secret and public, and we want to transfer the secret piece to watch only wallet. Next thing that we have to do is to use CLI to create watch only wallet. The first thing, we have to start Monero daemon, Of course, with StageNet, if we use Prune blockchain, we will just pull a part of the blockchain, not the full blockchain. This will be faster. So for testing, I encourage to use that parameter. And then in other console, we can start Monero wallet and generate from view key parameter gives us ability to provide the address and provide the secret for the view. And of course we're choosing some name of the wallet at the end. Yeah, and then we getting two questions. First is about our address, and second is about private part of the view key. Then we waiting for the synchronization of the StageNet blockchain. Of course, we're doing that just because we would like to create couple StageNet Moneros ourselves through mining. This is useful. We can use faucet like in case of Bitcoin, but in this case we just mine at our own Monero. This takes some time, but then we can spend our own StageNet Moneros. So when Monero D starts, we just typing start mining and giving our address, which we know from the cold storage wallet. And at some point, after some time, of course, after blockchain will be synchronized, this will take some time. But after some time, we will get the information I found block and hash and some additional information. That's not enough, because balance still will show that, okay, we have some Moneros like here, but the unlocked balance will be for some time 0. So it takes some time to make the blocks spendable, and we have to wait some time to make it happen. Because of the different mechanics of Monero in comparison to Bitcoin, to keep balance correct on the watch-only wallet, we will have to constantly synchronize both cold storage and watch-only wallet, because the balance is not updated because of the properties of the Monero. To do that, we're using two methods. First of all, transferred can be monitored by using export outputs command. So we exporting all outputs on watch only machine and importing inside cold storage. Thanks to that, both all the transfers are monitored in both wallets. And then every spend we made, we have to for every spend we made, we have to export key images on cold storage and import those on watch only. In that way, the balance will be updated. Yeah, so to unlock the balance, it may take even hour or more. So for me, it was one and a half hour, and after that, I could spend Moneros. This is how the account command output look like. So you can see that at this point I had 92 Moneros and 30 of them were unlocked, and I could spend that. To create transaction or transfer in case of Monero, we using command transfer, providing some address, and we at the end we pointing how much we want to spend. In this case, it is one Monero. And yeah, we seeing what kind of transaction it is, and we confirming, and in that way there is a file created, unsigned Monero transaction in the directory in the current directory of the wallet. Next, we taking this unsigned Monero transaction and transfer it to the Monero cold storage where all our private keys are stored. And we can use sign transfer command to sign this file. Of course, we are prompted with all the details where we're sending, that we're sending one Monero, and various other details about the Monero mechanics. This file, this unsigned Monero transaction, should be inside the current working directory of our wallet. where we run our wallet. And then when we can take this Signet file, so the Monero wallet will create Signet Monero transaction. We copy it back to the watch only wallet VM, and we can submit transfer to publish that transaction on the blockchain to let everyone know that this transaction was made. And this is done by submit transfer. It also looks for the Signet Monero transaction inside current working directory. Okay, so how we can turn that knowledge into RPC service? First of all, we have to create RPC service, and it requires root privileges. So we're starting a Monero cold storage terminal in Monero cold storage with root as a user. We create etc Qubes RPC test sign transfer in Monero cold storage, and this script looks as follows. We define where is our wallet. We taking all the standard in that coming during the execution of RPC and putting that to unsigned Monero TX file, and then we running terminal because there will be need for confirmation, which I will show in a minute during the demo. And then we, in this terminal, we just call our wallet in StageNet. We're pointing the wallet to be Monero StageNet wallet, which saying that there is empty password, and what we want to do is signing the transfer. Then in DOM0, we need a policy which will say what should happen when this kind of RPC is called, and then finally the send to sign in our machine where we have our watch only wallet. So first would be to print file to sign or transaction to sign, and then get all the output from the signing process, which will be signed Monero transaction file. Let's see the demo of the RPC. So first of all, we create a transfer to some address that I found. We're transferring one Monero, there is empty password. We confirm that we want to create a transaction with the fees, and you can see that unsigned Monero transaction file was created. And then we're calling QRexec client for Monero cold storage. We're using sign transfer, and as a parameter, we're using sign to sign script, which you saw before. And as a parameter, we're giving unsigned Monero transaction, and output going to signed Monero transaction. Now you see call, we confirm that we want to use Monero VM, and we get confirmation the window was very small, but there was also information about what kind of transaction we're confirming, where it's going, and so on. Then we have already signed Monero transaction file, and we can do submit transfer pointing to that file. Yeah, and we can see transaction that we submitting, and yes, we want to submit that, and we can show that transaction, that transfer was already submitted to the network. Yeah, and we see it's right now pending, but after some time it will be it will be out. Okay, so future ideas based on all the proof of concept we did, we get to some conclusion. There is a lot of things that could be improved. So let's start with some ideas that could be applied to improve this setups. For Bitcoin, it would be great to get confirmation of explicit amount spent in transaction which we signing. In Monero we have that because there is new terminal starting, and we just typing yes for the transaction. We see what's the amount of the transaction. We see all the details about the transaction. It would be great to have that in Electrum. Then we would like to have our cold storage VM in which automatically the wallet daemon is started, just for convenience. Then we should consider some protection mechanisms for the cold wallet VMs, this could be various things, even secure boot discussed before, some encryption. Next thing which is important, we should consider backups and disaster recovery. So we should look at the semi-automatic or maybe fully automatic way of backupping and then recovering from the broken state. In case of Bitcoin wallet, we should recognize PBST and transactions, so partial transaction file and full transaction files, because those could be used in various situations, and we're dealing with those differently. PBST are in binary and require conversion to base 64. Transaction are already text files, so this is these are two different types of files which we have to deal with differently. Then it would be great to have salt stack automation for VM creation for fully featured cold wallets. Then it would be even better and more secure to use multiple signature and have one hardware wallet. So then any transaction would require multiple signature. One could go from cold wallet, and we could create some policies according to that. So let's say amounts bigger than should require more signatures or something like that. This should improve the security of the solution. Finally, offline wallet software update should be considered, because right now in case of Monero, the suggestion that I saw online is just completely reinstall everything and recover the key, which could be kind of problematic because setting that all stuff together takes time. And for Monero, definitely improve at password handling, because right now we're giving this password parameter. We could ask about password if someone has some password set up, and this have to be handled by the scripts correctly. Then using CLI is also kind of problematic and should not be really is not recommended by Monero community to use CLI for this kind of operation, so we should consider RPC. Thank you for watching, and I'm waiting for your questions.